The core product of CropCycle is an AI chatbot, which is like ChatGPT, but it's a bit different. So you're getting the data from the farmers. It speaks Balinese, Javanese, and all the local languages. So the goal isn't to replace farmers' wisdom, but to amplify it with climate-smart tools that are actually usable on the ground. We can actually offset 50 million tons of CO2 in 2050, and we can also improve the GDP per capita of Nepal by $50 by 2045. Farmers won't care how much CO2 are they sequestering. They only care what kind of food do they can put on the plate for the family, as well as the money that is needed to sustain their livelihood. When you have a huge database, you can actually pinpoint the issue and realize that why is the same crop being planted in the mid-hills versus the valley different? Why is it failing here, or why is it not here? So then we can look at the issues. That huge database, that's a huge power tool that you can use, because the more you know, it really helps you make the decisions with with more accuracy, so that the impact of the project will be more feasible.
So like, what is the core concept behind your like AI or like those technological things?
That's a good question. I think the core product of CropCycle is an AI chatbot, which is like ChatGPT, but it's a bit different. So you have like a circle, and it connects to three points. The first one is a continuous feedback loop. So you're getting the data from the farmers. When, like, say you are a farmer in Japan, and you're texting the chatbot using a WhatsApp API because it's a low bandwidth, because maybe 5G and 4G is not available in all areas, especially in Nepal and Indonesia. I'm not sure about Japan. But what should I plant this season? How do I apply biochar for soil health? How much carbon offset do I get? And how many yen, Japanese yen, or how many Nepali rupees do I get from that? And most importantly, how much carbon am I storing in my compost? So I think we target to speak multiple languages. For example, in Nepal, it could speak Hindi, Gujarati, Nepali, and in Indonesia, it speaks Balinese, Javanese, and all the local languages. And the way it works is that when you input the data from your farming coordinates wherever you are on the earth, technically, specifically like Nepal or Malaysia or Indonesia, where we're doing this project, I think you will get all this data, but our job is to figure out how we can utilize this data and benefit just both corporates and bring that money back to the smallholder farmers. So kind of like a circular system. And behind the scenes, we're actually integrating real-time climate data from the Ministry of Agriculture in these countries, and the regenerative agriculture standard operatings and procedures, and a simple carbon calculator. But on the surface, it's like a helpful friend who speaks their language and understands your land. So the goal isn't to replace farmers' wisdom, but to amplify it with climate-smart tools that are actually usable on the ground.
Thank you. So like, how was that kind of system or like those technology was made?
Okay, so if you're talking about the back end, for a minimum viable product we did back in December, we use Zapier. So Zapier is an automated process flow that connects, for example, OpenAI ChatGPT to an API, for example, like Google or WhatsApp. And then you also can connect it, for example, to the database, which is something that is confidential and only works with our own internal custom knowledge database. So obviously it's not open source because this is something that we built. So how do we actually build this database? One of the ways is to collaborate with the ministries of agricultures. So I'm in talks in Malaysia, and we're building the team in Indonesia to start having that conversations at least in Bali to prove it is a scalable MVP pilot. But also in Nepal, we've already engaged with the municipalities. So in Malaysia, Indonesia, and Nepal, we've been doing a great job in building their directive. But we can also look into another way, for example, using drones. So for example, DJI, the ones from Shenzhen, DJI multispectral tree. There's so many kinds of drones, but there's specific agricultural drones that can do research scanning of like 200 hectares or acres of land. And inputting that to our database, I think that would very benefit the overall AI to optimize that for, let's say, a farmer in Central Nepal, because obviously it's different for the altitudes, the latitude of where you are. So in Nepal, there's three regions. There's the Himalayan, so like Mount Everest, like the top
Mhm.
part, and in the middle, it's called the Terai region. The mid hills. So the mid hills where Kathmandu is at, and it's a kind of transitionary between the Himalayan mountains to the valley down south. And then in the bottom, it's called Terai, and Terai is Nepali for the valleys, and that's where all the fertile land is. But the thing is, I think because of not I think from research, actually, under unpredictable climate change, forces the farmers and also the people in Nepal to import this from north of India because India is much more competitive market. It is cheaper, but at the same time, we cannot neglect that this also affects the GDP of Nepal. So looking at our research with the integration of CropCycle, we can actually offset 50 million tons of CO2 in 2050 versus the status quo if CropCycle didn't exist. And we can also improve the GDP per capita of Nepal by $50 by 2045. So looking at that on how even if it's $50, it's a huge chunk out of their actual GDP per capita, which is almost $1,000. I think it's $800, which is not a lot. But looking at how it's a catalyst, in fact, I think it creates a domino chain where if you improve one sector of the economy, it kind of dilutes into the overall economy as well. So not just thinking about how we can solve the issue for climate change, but also the economic empowerment that will benefit the social aspect of the community, or at least the citizens of Nepal or Bali or Indonesia or Malaysia. So that's basically how it works. Yeah.
Oh, 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 okay. So for last, can you walk us through a typical user journey, like what kind of farmer experiences when using your product?
Okay. Okay, let's imagine we are a farmer in Nepal, and because the chatbot is designed to be low bandwidth, multilingual, and as AI assistance for smallholder farmers. So what you get, if I'm a farmer and I utilize it, I have my phone over here and I'm using my WhatsApp, then I would get the crop recommendations based on where I am, the climate, and the season. And we also have the season database from our internal because it is something unpredictable, but with enough research, we can actually simulate that through a weather modeling. And then you also have guidance of regenerative practices in their languages. For example, how do you do compost, biochar, intercropping, and what's the difference? And you also have carbon tracking. So how much, like the estimation of the CO2 sequestration per action and the market and training updates. So for example, how much is the rice being sold in India or Nepal? Getting that data will be very beneficial because you wouldn't want to get cheated on by
Yeah.
someone if you're selling it the wrong price. And also local advisory alerts and the farmer profiling for tailored advice. So for example, the age, how old are they? How old am I if I'm a farmer? What's the land size? Do I have 2 acres of land? Or what kind of crops am I planting? And why is it failing? And then sometimes for centuries and generations, it's always been working well. But with climate change lately, it's been very hot. And I think there's more heat waves and flooding and very much uncertainty, also more disasters like earthquakes. And I think that's also factors that is out of my control, but we can use this to simulate is it worth it to proceed with this in the long run? So the farmer sends a message through WhatsApp, like, what can I plant in July? How do I make biochar from bamboo, for example? And Zapier reads the incoming text via webhook, for example, WhatsApp, Twilio, and webhook, and it matches the query using a keyboard-based routing logic or sends it to OpenAI ChatGPT for intent detection. So that triggers a backend workflow. So it looks up the weather and crop data from a Google Sheet from our internal database. And then it also looks up standard operating procedures from Regenerative Agriculture Playbook. So that could be hosted on Google Docs or embedded database. And if it's carbon related, then it calculates the impact of using a carbon equivalency calculator. For example, 1 kilograms of compost equals to how much carbon CO2 is saved. So that layering, it sends an automatic message back to the farmer through the same platform with the answer, which is like best crops for seasons, a link for the documents that would help the farmers in a visual way, and call to action. Join the local training co-ops. So we noticed, just to add one thing, farmers won't care how much CO2 are they sequestering. They only care what kind of food do they can put on the plate for the family, as well as the money that is needed to sustain their livelihood. Now, we are not collaborating directly with smallholder farmers. We're actually directly with co-ops, so the ones that are in charge of the village. And this is the 63 municipalities that we have currently engaged with. So by by building our MVP chatbot backend with our tech and data team, and having the money from the finance team to, for example, print papers, to print the QR codes, that's how we built the minimum viable product towards that. So we've done the MVP before, but 200 people is not enough. So we're looking to scale that to 8,000 to 10,000 people minimum, which is a fair reach when you have an access to an outreach of almost 200,000 farmers. Yeah.
Thank you.
So we're moving on to the next question. So how does the system calculate carbon C how do you read this?
Carbon CO2, yeah.
Yeah, sorry. In
It's
real time. Like how does it work in real time when you are being asked?
from being asked from the farmer or from the chatbot, you mean?
From the chatbot.
Okay.
Yeah.
Okay. So for that carbon sequestration, I think that is something based on our internal database that we are currently building on. So we can take figures that are already online, but with our agriculture and carbon team, that's something that we're building towards to the right number for that. Because how much carbon sequester work, we can only work on estimations. For example, bamboo, each bamboo has different CO2 sequestration because they are a grass, but they are completely different, even though they are part of the same family species. So for example, a gigantocloa, like a scientific name for a bamboo, would be different than the other species. So it works the same way as crops. But calculating that is something that we're onboarding with the team. So I cannot give you an exact number for now, but that is something that we take in consideration. So for example, how much carbon sequesters in the mid hills of Nepal for wheat is actually different from how much carbon the wheat sequesters carbon in the south of Nepal, which is the valleys, because of the latitude, the altitude, the weather, the humidity. It all takes into consideration of that. It's not more so that it is an estimation, and we will work with that. I think we will try our best to work into the details so that it is very transparent for the corporates and investors to see the impact that we do per dollar. And at the same time, the smallholder farmers, not only it empowers them, but also can feel good that they are doing a big share of solving a sustainability and regenerative issue. So yeah, I can't give you much information on that. Apologize, but that's something we're building with the agriculture team, led by Eliana, which is a Dutch girl that works in Kenya for composting. And with that team, I strongly believe that we're able to build the internet database because the CO2 sequestration requires a lot of tools. There's many tools that requires it. Because, for example, if you're doing CO2 research on land, like on a forest, it's different for how, let's say, you do CO2 sequestration in coral reefs. So even though when I was working as an ESG consultant in Bali, I did coral reef conservation. So going snorkeling and calculating the carbon the corals, how much carbon did they sequester. But when you're talking about agricultural land, the farmers, you don't know that. So I think that's why you look in Google Scholar and research on research journals to figure that out. But I think it's not just enough if you're doing it on your own. So that's why we have a team for that to build that database.
Okay, thank you. So the next question is gonna be about another question about the chatbot. And could you
Okay.
tell us about how does the user input helps to improve the chatbot through the machine learning?
Okay, so for the user input, I think there's a data structure and logic. So we're keeping, I can speak about the MVP first. So the MVP, we want it to be lean, we want it to be modular, and we want it to be human curated to reduce the hallucination and cost. So how that works, we break it into four. We have the crop data sheets. So these are tables, like whether it's on Google Sheets, of seasonal crops by region. So if I have Nepal, then it will be very detailed. It'll be a long set of details. That's something that our team is building by region, but also the planting guidance for how you plant for each of that. Then we have the second, which is the SOP library that we're building, the Standards Operating and Procedure Library. So that is, for example, the PDF and the text files that covers the regenerative methods. The third would be a carbon tracker. So that's the simple calculator logic. But with the calculator, we still need to get the data right to curate a proper calculation for that. So like 1 ton compost equals to how many X CO2, kilograms of CO2, for example. Then the fourth is the farmer profiles. So putting the basic inputs like the land size, the crop, the age of the farmer, where they're from, the climate zone. And we actually, let's say when we're building this, and we actually noticed a bit of a unique takeaway from this, is that when you actually get farmers from different parts of Nepal, and let's say a farmer in the south knows that this crop is doing well, and the farmers in the center maybe knows that it's not doing so well. When you have a huge database, you can actually pinpoint the issue and realize that why is the same crop being planted in the mid hills versus the valley different? Why is it failing here, or why is it not here? So then we can look at the issues. Like, for example, was there flooding lately? Was there unpredictable climate change? The way because of the Himalayan mountains, the way the wind flows through it, was there any changes from neighboring countries like India? Was there pollution, etc.? So that data from this, the Circle Continuous Knowledge Database, the generative AI architecture for the chatbot, and also the internal custom knowledge database. These are all data stored in a Google Sheets or Airtable for now. And we'll connect that with a tool like Zapier. We're actually thinking to change the tool to something more scalable, but and the MVP, we're using Zapier for quick retrieval and updates. So we're sourcing the farmer database through local government partnerships and NGOs. So for example, in Nepal, we're partnering with municipal cooperatives and agri NGOs who have registered database of up to almost 200,000 farmers for now. So we're onboarding them via bulk WhatsApp invites or voice calls. And that will be coordinated through Gunjan and Lekna, which is from the CropCycle Nepal team. For Indonesia, we're piloting in Bali with Astung Karaway that includes 150 plus farmers. So we're expanding via regional, we call it Desa Wisata, which is eco-villages in Bali, and Komunitas Petani Muda, which means the young farming community. So we aim to link that with Dinas Pertanian, which means Agriculture Office in Indonesian, and the P4S Institution for farmer data. And in Malaysia, we're working on a pilot with agroforestry partners in Kedah, a state north of Malaysia. And we're planning to integrate with Felda, Risda, Mardi. You won't know this because it's a big conglomerate that focuses on agriculture. And we're building that database for crop types, the farmer clusters. So we have the Malaysia team to focus on the support, the local outreach, and the translation. So with that being said, I think there's the structure that it takes time to build this MVP, but I'm sure by end of the June, the sprint for what each of the fellows will contribute could accelerate the finalization of the minimum viable product.
So like the farmer's information, all like the data from the chatbot makes like a huge big database, and you use it to improve the farmer's farming.
Exactly, which is why we're piloting this year, and we're planning to launch it next year in terms of how as we're starting getting revenue. And so right now what we're doing is refining the business model, the market the value proposition, the market research, more detail. And then on the sideline, I'm also using this program to empower youth change makers. So people in their 20s up to their 30s, people who are very interested in sustainability, but also regeneration, because sustainability just sustains, but regenerative agriculture sustains, but you have an excess, that like a spillover effect. So that's the difference between these two terms. And putting that in that context, that huge database is people say when there's information, that's a huge power tool that you can use, because the more you know, the more it really helps you make the decisions with proper with more accuracy, so that the impact of the project will be more feasible.
Okay, thank you very much. So the next question is about